Hello and welcome back to Cyber Hero. Today in this video we're going to discuss cryptographic hash functions. This will be chapter 6 of module 4. We're continuing. So let's begin. What we are going to see here, some introduction part, then some properties, and some algorithms and their applications, and hash collision. We're going to discuss this. And what is the difference between hashing, encryption, and encoding? And in last, we are going to summarize this video. So let's begin. Before introduction part, if you are new here, please make sure you have hit that subscribe button. So now, moving to the introduction part. What is a cryptographic hash? The function converts any input into fixed hash or digest, used for integrity and security. What does that mean? Actually, a cryptographic hash function is a mathematical algorithm that converts any input data into fixed size output. That's called a hash or digest. For an example, hello, its hash is 2CF something something when we use some algorithm. The output is always fixed length, unique, extremely difficult to reverse. Now moving towards the properties of a good hash function. It's a deterministic, fast computation, pre-image resistance, collision resistance and the effect so on. What does the deterministic means? Same input is equal to always same output. Fast computation, hash must be generated quickly, even for a large files. Then pre-image resistance, impossible to find the original input from the hash. Got it? Then second pre-image resistance, it means harder to find another input with the same hash. Collision resistance, in simple, what does it mean? Two different inputs should never produce the same hash. Avalanche effect. What does this mean? It means small change in input, completely different output. Now here is written a small change in input should produce a significantly different output. For example, capital hello and small hello should produce different hashes. I hope you got these properties. Now moving towards next, some common hash algorithms. MD5, SHA1, SHA2, SHA3, password hashing, so on. So MD5, what are the properties of MD5? 128-bit output always. It's very fast, but it's not secure. Collisions are easy to generate. Use it for checksums, not security. What is SHA1? SHA1 is 160-bit output. Mode, it's what was the previous one? MD5 128. This one is 160-bit output, more secure than MD5, broken and not requirement. Google domestic collision 2017. What is the SHA2? Secure, widely used. Main thing includes SHA 224, 256, 384, so on 512 वगैरह. It is a widely used, strong security, used in TLS, SSL, password hashing, blockchain. SHA3 is the newest version. It's a newest standard, resistance to modern attack technique, designed using CAC algorithm. How you pronounce it? KSCCAK. I don't know how you pronounce it. CAC algorithm. Then some password hashing. So now what are the applications? First main application is integrity checking, data integrity checking. Hashes detect change in files. Example, software website is display. SHA-256 checksums. Then digital signatures. I have made a separate video on this digital signatures. If you didn't watch that, please go and check that video. What are digital signatures? Instead of signing entire data, sign its hash. Then password hashing. System stores password hashes, not actual passwords. Then blockchains. Blockchain, each block refers to the hash of the previous block, ensures tamper resistance. Then HMAC, message authentic codes. It provides integrity, authentication, used in API security, JWT tokens, so on so on. Now, what do you mean by hash collisions? A collision occurs when two different inputs produce the same hash. Insecure algorithms like MD5, SHA1 have many known collisions. Example, two different freedom files with identical MD5. Now, what is the difference between hashing, encryption, encoding? Technique, for example, when we go for hashing, what is the purpose of hashing? Integrity. It's reversible? No. What is the purpose of encryption? Confidentiality. It's reversible? Yes. What about encoding? Encoding. The purpose of encoding data conversion. Is it reversible? Yes. So only hashing is the technique which can't be reversible. The main purpose of the hashing is integrity, data integrity. So this was about hashing, encryption, and encoding and overview. If you want a dedicated video, I will go through that. Please let me know in comment sections. Last, we are going to summarize this video. Hash function provides integrity and play major roles in authentication, blockchain, and password security. So it ensures integrity, authenticity, efficient data verification. These are essential in password security, blockchain, digital signatures, and secure communication. I hope you learned something new. If you learned something new today, please hit that subscribe button and share the video with your friends as much as you can. It means a lot to me. Thank you. Bye bye. Take care. See you in next video.